Okay. Number 3. We're kicking off from a ground level with an initial velocity, but now we do have some vertical velocity, okay? So this one's going to be different than the last two. Here we're kicking it from here, and the ball's doing that. This is a 30-degree angle, and our initial velocity is 27 meters per second. Now, what is our initial velocity in the y, and what is our initial velocity in the x? Well, our initial velocity in the y, sorry, that's x. Our initial velocity in the x is going to be the cosine. So that's going to be 27 times the cosine of 30. Okay, so that's 23.38. Make sure your calculator's in radians. Okay. The opposite, that's the sine. That's going to tell us our vertical initial velocity. So that's going to be 27 sine of 30, which I think is just half of 27. Indeed, 13.5. That's a special right triangle. Okay, so now we have our initial velocity broken up into horizontal and vertical components. Now, to me, look, we know this. So far, what I've learned is that the most important equation for me to put is that y final. You can tell where y is at any point by doing y initial plus the velocity in the y direction times t plus 1/2 times the acceleration in the y direction times t squared. We've used this every time. Well, that's just a quadratic, right? So y is going to be negative 4.9 t squared, and then plus 13.5 t. You see that? Well, I think what I want to do is I want to answer C first. We want to know, where does that thing hit 0? And so I can just plug this in my John Rick. I could solve it by hand. I could graph it. There's a lot of ways to do this. It's negative 4.9. Well, I don't need to. Hold on a sec. I'll just solve it by hand. 0 is negative. 0 is. Uh-oh. T times negative 4.9 t plus 13.5. Again, if you want to, just solve this in your John Rick or graph it, figure out where it hits 0. There's a lot of different ways to do this. I would do that, but I think here I'm just going to show you how to do it by hand. So t is either 0, well, that makes sense because it's 0 right here, or negative 4.9 t plus 13.5 equals 0. So let's solve that. Negative 4.9 t is negative 13.5. So 13.5 divided by 4.9. So t, how long did it take for it to reach the ground? 2.755 seconds. Notice I solved that out of order. What is the maximum height of the ball? Well, to find that, the easiest way to do it is take 2.755 and divide it in half, and you get 1.3785. 0.76, I guess. Comma. Well, if you just put that in, that's going to give you the maximum height. Or why don't we just do this? We could just do everything in our graph calculator. Y equals, where'd it go? Negative 4.9 t squared plus 13.5 t. Negative 4.9 t squared plus 13.5 t. Oh, look, this is exactly what we want it to look like. Okay. This right here is the maximum height. So if we just go calculate maximum, enter. Oh, no. Oh, no. Calculate maximum. I'm so done with this touch screen. I'm just going to use my mousey. Get to the left of it. Hit enter. Get to the right of it. Hit enter. Enter. There it is. It's exactly what we thought would happen. After 1.3775 seconds, this ball has gone 9.29, 9.30 meters. So this, the maximum height, is 9.30 meters. I want you to know there's lots of ways to get that. And then how far away did it land? Let's just go calculate 0. We already found the x value, but we need... Oh, no. Hold on. Time out. Let's go back to that. For that, I need distance equals rate times time. For part C, I need distance equals rate times time. Distance is what we're looking for. The rate in the horizontal direction is 23.38 meters per second. Okay. Times, how far did it take to get there? 2.755. And that's going to give us our distance. Times 23.38. And you're going to get 64.4 meters. All right, tough question. I'm starting to enjoy this stuff. Boom. Boom.